Hello everyone. So today I want to talk to you about a method that's called the Petrus method, and it's an intuitive block building method that does not use any algorithm, just like the eyes method that I showed you some time before. So let's start the method, which includes making a 2 by 2 by 3 block first, and this is what we will do. It takes some practice to actually be able to do this first step, because it's intuitive. So it's this block here, or this block here, and these are two blocks. So it's that's why it's called 2 by 2 by 3 block. So what you do now is you twist the cube in a way that the block is on the bottom right of your cube, and now you're gonna have to make 2 crosses. You have to orient all the edges of the last layer and of the left side, and let's see how we can like start. For example, here I can see that I have a white which is oriented in the right way, because if I put it in the upper layer, it will get solved. This one is badly oriented instead. And for example, I don't know, this one is also badly oriented. So what we do is we put this one here and this one on the left side. So you always have to have one on the left side and one on the upper right side. And you perform like this set of moves, which is like 4 moves or something like that. So it's 1, 2, 3, and 4. So as you can see, I fixed this one and the edge, and the green edge. And now, as we can see, we are left with another 2 edges which are badly oriented, because this one is correct. If you can see, if I move it upstairs, it's okay. It will show white. This one as well, if I move it upstairs, shows white. But these two, this one and this one here, are not correctly oriented, because, for example, if I put this one on the left cross, it will not match. There will be orange. Instead we need a green here. Same thing applies to this edge. It's switched. You have to put the green here and the red here. So we do the same thing as before. We put one on the left side and one on the upper layer on the right side, and we do the same pattern that we did before. So it's 1, 2, 3. As you can see, they are both solved, and 4. And so you have all the edges correctly oriented on the top side and on the left side. So now you make like a little square, 2 by 2 by 1 square. And obviously this is also logic. There is no algorithm that can help you. For example, I can see this one can get solved with this corner. So what do? If we move the corner immediately and we try to match them, it will not get solved. You see, they are like inverted. But if we move this edge 180 degrees, and then we put the corner next to the edge, it will get solved, you see? Okay. And now you have to align this one, which is green, yellow and orange. You already aligned it with the green and yellow edge. Now what you need to do is align it to the green and orange edge. And so you it's for moves here. You don't need me to explain. You just watch how I can for example put this two it's called pair, this one pair here on the bottom side, on the top side. And now if I move this one away and move this edge 90 degrees, I can put the pair back and it will create a square, which you can place in its correct position, which is here on the orange and yellow sides. And then you see the top. Obviously don't mix up the cross, so if you need to, just do a few moves like that to keep the cross in its correct position. And now for example you have to see how the edges are oriented. But firstly I like to solve my last pair. You can either solve the last pair first or the edges first. It doesn't really matter. In this case I will solve the edge first. So the edge, as you can see, is the pair is this edge, this red and green edge, and this red, green and yellow corner. So for example, if you put them together like with a 180 degrees move, it doesn't get solved. It's inverted again. So it's again in this case it's an algorithm. It's a little algorithm, which is, it goes like that. So it's right inverted, up inverted, right up, right inverted, up inverted, right up, right inverted, up inverted, right up. And that's how you solve the edge. There are different cases. It could be, in any case, it could be this way. It could be put in this combination. For example, the two red are matching, or for example the two green pieces are matching. You always have to know that you have to make the pair. In this case it's another small algorithm. It could be if the red is matching, actually it's correct, but if the green are matching, you can do like left inverted. You can use like the same movements that the Friedrich method would use. Up inverted, left, up inverted, right inverted, up to, left, up to, left inverted, up inverted, down. So that's another case. There are other cases, but I cannot show all the cases There are like a few. Could be like that, where like the green and the green are opposites, and here there is red and yellow, so it doesn't really make any sense. But you can always do like up, left inverted, up inverted, left, and then if you want to keep the cross, you have to do a few extra moves in order to keep the cross oriented. In this case, I can't explain every little move I made, because these combinations have to be studied individually and by yourself, because there are no algorithms that can bring you there. Now instead there is an algorithm, because you can see these two are matching. The one is green and the other one is red. They are in the correct sides, but here, for example, the orange and the blue are not matching. So what do? You put these two that are matching on the left side, and you do this little algorithm, which is left inverted. So you move this pair here, you move it to the right, then you go down, then you move it to the right again, then you go up again with the row, and then up twice, down. And as you can see, all the edges are now solved. The edges are these ones in the middle. They are solved, as you can see. And as a last step here, you have to position the corners firstly. So see firstly if you have any positioned corner already, but there aren't any. So you do the algorithm once, and then you see, for example, this one is in the correct position now. It's orange, white, and blue, which is in the orange, white, and blue side. But for example, here you can keep this one on the right side, and then do the same algorithm to move the other three in the right position. So the algorithm goes like that. So it's up, then you move the right, move up, move left, up, right again, up again, and left again. And now you can see that they are all in the correct positions. For example, this one is orange, white, and green, which goes in the orange, white, and green side. This one is orange, blue, and white, which goes in the orange, blue, and white. And from here, the last step is to use a commutator, which will solve the cube, basically the rest of the cube. So for example, this one has to move in a clockwise way, and this one has to move counterclockwise. So starting from the counterclockwise, you do down, you go down with the right, then you go take it away, go up, bring it back, go down again, put it again, and go up. Then you move the other corner, and don't worry if you have mixed it up, because you'll do the moves but inverted. and you see I solved both of them. Same thing you do to the other two corners. Oh, sorry. Oh, I mixed it up actually. At the very end. No. Okay. And the cube gets solved. And that was the Petrus method, guys. Thanks for watching, and bye.